Okay, so we had a couple of questions from our online Zoom session this morning, and this was one of them. How do we do this? So this is a definite integral, so our first step would be, okay, we're looking at the integral of e to the x. Well, we know that this is simply going to be e to the x. And we're looking between 0 and ln 2. And that means we're going to have e to the ln 2 minus e to the 0. So I've just put in these values. Now, hey, wait a second. You know, when you're dealing with something like an e and an ln, they are like the inverse of each other. So they cancel each other out. So e to the ln 2 is simply equal to 2. And minus e to the 0, which is 1. And so our answer to this is simply going to be 2 minus 1, which is 1. If you are unsure, you can easily do this on your calculator. Just press shift E, and then in that, in the little box that comes up, put ln 2, and you'll see that this is so. So some of you are stuck on number 5 from exercise 3.2. The first thing is, I decided I was going to sketch these graphs, and all I did is I just chucked in 0, 1 and 2 for both of them. So this one here, the red one, is simply 1 over 2x plus 3, and the blue one is 1 over x minus 3. I just chucked those values in because we are trying to find the area between the bounded by the graphs, so this and this, the y-axis here, and x equals 2. So we're trying to find this area here and this area here and adding them together. So we're going to do the integrals for each of them between 0 and 2. So let's start with our red one. So my first one is going to be the integral of the red one. So that's 1 over 2x plus 3 dx. And that is simply going to be half 1 over a ln modulus 2x plus 3, and we're doing that between 0 and 2. Let's just chuck in our values here. This is going to be half ln 2 times 2 is 4 plus 3 is 7 minus half ln 2 times 0 is 0, so ln 3. Simplify that to half ln 7 over 3. That's our first one. Now let's move on to our second one. The integral between 0 and 2 of 1 over x minus 3 dx. And I can say, well, that is equal to 1 over a, which is 1 over 1, ln modulus x minus 3 between 0 and 2. Chuck in a 2 here. 2 minus 3 is minus 1, but with the modulus we're going to have equal to ln 1. Minus, chuck in a 0 here, we get ln minus 3, but modulus, so ln 3, and we can say that's ln 1/3. Okay guys, so we've got our two areas, here and here. The last part of this is where it gets a little bit tricky. You have to remember that in integration, when you have an area that is underneath the x-axis, such as this one here, that is a negative value, and to add the areas you have to turn it into a positive value. So I'm going to say, when I add them together, I'm going to say it's 1/2 ln 7 over 3 minus ln 1/3. Okay, this is going to give me this as a positive area now. Okay, you chuck in ln 1/3 in your calculator and you're going to get a negative answer, but the area can't be negative, it's got to be positive when we add them together. So that's why I've done this. Now the next step, I'm going to say 1/2 ln 7 over 3 minus, and I'm going to turn this so that we've got a half in front of it as well. Now remember, a half is just like a square root. So for me to square root this must be 1/9. If I take the square root of 1/9, it gives me 1/3. Okay, so this is the same as this, but now that we've got this half here, we can say, maybe I'll make a bit more space up here, we can say that that is equal to 1/2 ln 7/3 using our log rules divided by 1/9, which is 1/2 ln 21. You can just check that. You can go 7/3 divided by 1/9 is the same as 7/3 times 9/1. Cancel, cancel. 3 7s are 21, 21/1. Okay, so I hope that helps you understand how that one works. A couple of tricky ones there. Just remember that when you do your log rules when you're working with these. And secondly, remember that if you've got an area underneath the x-axis, that's going to be a negative area, and when you're adding an area above and an area beneath, you need to turn that negative one into a positive so you get an overall positive total area. Alright, I hope that helps. Good luck.